Point your phone at a cat. It draws a little box, types the word cat, done. A child can do it, a cheap phone can do it, it feels like nothing. Now ask for the opposite. Not is this a cat? Instead, invent a cat. A brand new photorealistic cat that has never existed, never been photographed, not a copy of any real animal, and it has to look completely, convincingly real, fur and whiskers and a glint in the eye. Suddenly the easy thing is impossibly hard. Recognizing a cat and inventing one feel like cousins, but they are not even in the same league. One is a quick glance. The other is conjuring a whole world that is internally consistent, down to the last pixel, out of essentially nothing. That gap between spotting a thing and making a thing is the entire subject of this season. Every image model, every video model, every voice and song and three-dimensional object an AI produces is an answer to one question. How do you invent something new that looks real? Today we build the single idea that all of it stands on. After this, the rest is detail. If you have watched the first season, you have already met one half of this. We spent a whole episode on a model that can look at a picture and tell you what is in it. Pixels go in, meaning comes out. Is this a cat? Is this a stop sign? What does this chart say? That is reading an image. The machine squeezes a huge grid of pixels down into a short answer. Now here is the move that opens this entire season, and it is almost embarrassingly simple to say. Take that same idea and run it backwards. Instead of pixels in, meaning out, go meaning in, pixels out. Instead of squeezing an image down to a label, expand a few words up into a whole image. A model that reads pushes a picture down toward meaning. A model that generates pushes meaning up toward a picture. Same world, opposite direction. And that opposite direction, going up instead of down, from a little information to a lot, is exactly the hard part. We are not going to re-explain how a model reads. We are going to spend the season on the reverse trip, because the reverse trip is where all the magic and all the difficulty lies. Let us be precise about why the reverse trip is so much harder, because the reason is the foundation of everything else. A recognizer has it easy in a way that is worth stating out loud. It only has to sort. Show it a photo, it picks a bucket. Cat or dog, spam or not spam. There is a right answer, and the job is to draw a line between the buckets. Researchers call this a discriminative model because all it does is discriminate, tell things apart. A generator gets the brutal version. There is no single right answer, and no buckets to choose from. Asked for a cat, it cannot pick from a list. It has to produce a specific arrangement of 1,000,000 pixels that, taken all together, reads as a real cat, and there are countless cats it could validly make, and overwhelmingly more arrangements that are pure garbage. Sorting into buckets versus building a whole new thing from scratch. One narrows the world down to a word. The other has to widen a word out into a world. The standard name for the second kind is a generative model, and the leap from telling things apart to making new things is the leap this entire field is named for. So how on earth does a machine build a believable image out of nothing? To see it, we need one picture in our heads, and it is the picture this whole season runs on. Think of every possible image as a single dot in an enormous space. Not a metaphor, a real coordinate. A small color image, just 256 pixels on a side, is a list of around 200,000 numbers, one for the brightness of each color at each pixel. So that one image is a single point in a space with 200,000 dimensions. A bigger photo lives in millions. We cannot picture that, so for the rest of the season we will draw it flat as a plane but keep the real scale in mind. It is vast beyond imagining. Now ask the question that cracks everything open. If I stand somewhere random in that space and read off a picture, what do I get? Not a cat. Not anything. You get static. Snow. The gray fuzz of an untuned screen. Pick another random point, more static. Another, more static. You could pick random points until the heat death of the universe and never once land on something that looks like a real photograph. Almost the entire space is noise. Here is the twist that turns an impossible problem into a solvable one. The real images, the ones that actually look like something, are not scattered all over that vast space. They huddle together. They sit on a thin, curved sheet running through the middle of all that static, a vanishingly small sliver of the whole space. Researchers call this sheet the data manifold, and the bet that it exists is called the manifold hypothesis. Here is why it is believable. A photo of a face has millions of pixels, but it does not have millions of independent choices. To describe a face, you really only need a handful of dials. Which way is it turned? How is it lit? Whose face is it? Is it smiling? The honest estimates put it on the order of tens of real knobs, not millions, a rough figure with wide error bars, not an exact count. Every legal face is just some setting of those dials, so all the faces in the world pack onto a thin surface with only roughly that many true directions, floating inside that 200,000 dimensional ocean. Cats live on their own thin sheet, mountains on another, handwriting on another. The space is almost entirely empty, and all the meaning is crammed onto these thin, bright surfaces. Now the whole problem of generation can be said in one sentence: get onto the sheet. And now the single most important idea in the season, the one every method you will ever hear about is a version of. We have two places. There is the easy place, a loose cloud of pure random static which is trivial to make. Your computer can spit out a fresh patch of random noise 1,000,000 times a second without breaking a sweat. And there is the hard place, that thin, bright sheet of real images, which we have no direct way to reach. So here is the whole trick. Do not try to jump straight onto the sheet. That is the impossible leap we started with. Instead, learn a path. Start at a random point of easy noise and take a series of small, guided steps that carry that noise, bit by bit, until it lands on the sheet as a real image. At every point along the way, the model has learned to ask one question. From here, which way is more real? Then it nudges in that direction. Step, nudge, and a field of static slowly resolves into a face, a fox, a city street. Generation is not painting. It is not pasting. It is a guided walk from noise to data. Every single family of generative model, all the names you are about to meet, is just a different answer to one question. What is the best path from the static to the sheet? Now I have to correct the single most common misunderstanding about all of this, because it changes how you see everything the AI makes. When the model produces a brand new cat, it is not reaching into a giant photo album and pulling out a stored cat. It is not stitching a collage from pieces of pictures it has seen. And it is not taking a real photo and cleaning it up. There is no album inside. What the model actually learned during training was the shape of the sheet itself. Not the individual photos, the region where real cats live. Show it millions of cat pictures and mostly it does not memorize them. It learns the lay of the land, though it can sometimes echo a picture it saw too often. What makes a cat arrangement count as a real cat, and what does not? Once it knows the shape of that region, it can produce a brand new point inside it that was never in the training data and never existed anywhere. A genuinely new cat that nonetheless obeys all the rules of being a cat. The technical way to say it is that the model learned the distribution of a kind of data and then drew a fresh sample from it. That is the real definition of generative, the one to carry for the rest of the season. Learn the distribution of a kind of thing, then sample a new one. Not retrieval, not collage, sampling. Two honest caveats before we go on, because this season earns your trust by being precise where it is easy to be sloppy. First, the picture I just drew, the clean, bright sheet, the tidy dials, is an intuition, not a literal map. Real images do live on something like a thin surface, but it is wildly folded, curved, and tangled, nothing as neat as a ribbon. The ribbon is a teaching tool that points at a true idea, not a photograph of the inside of the model. Second, a beautiful warning about that vast space, one we will return to later. You might think the safest image, the most cat-like cat, sits right at the bright center of the cat region, at the single most probable point. It does not. In these enormous spaces, the single most likely point, the peak of the distribution, is usually a weird, washed-out gray smudge that looks like no real cat at all. The convincing samples do not sit at that peak. They live a little out from it in a thin shell around it. That is deeply counterintuitive, and it is one of the reasons generating well is subtle rather than obvious. File it away. For now, the headline holds. Almost all of image space is static, real pictures hide on a thin sheet, and the machine's whole job is to walk from one to the other. Here is the payoff for sitting through the abstract part. That one idea, learn where a kind of data lives, then walk fresh noise onto it, is the master key to this entire season, and to almost everything you have seen labeled AI art, AI video, or AI music. Want images? The data is photos and the sheet is the space of real pictures. Tools like Midjourney, Stable Diffusion, and Flux all do exactly the walk we just drew, and the names will keep changing but the walk will not. Want video? The data is short clips. The sheet lives in an even bigger space because now time is a dimension too, and systems like Google's Veo and Kling are walking onto it. Want a world you can move around in? That is the same idea stretched until the model generates the next moment of a place as you explore it. Want sound, music, a singing voice? Swap pixels for the shape of a waveform and the sheet becomes the space of real audio, which is how tools like Suno make a song. Want a three-dimensional object you can spin around? Same key, different data. One idea, worn as many costumes. For the closed, commercial tools, the labs do not publish the exact recipe inside, so we will teach the open mechanism that everyone shares and be honest about where the public knowledge ends. One last promise about the road ahead so the jargon does not scare you when it arrives. You are going to hear a wall of intimidating words: diffusion, flow matching, GANs, autoregressive models, variational autoencoders. It sounds like a dozen rival warring technologies, and that is exactly the wrong way to hear it. They are not rivals. They are different routes for the same walk, from the same static to the same sheet. Some take many tiny, careful steps. Some try to leap in one bound. Some build the image piece by piece. Two of them, diffusion and flow matching, that get talked about as competitors, are in the deepest sense the same method, just described two ways. Flow matching is the cleaner, more general way of saying it, and ordinary diffusion turns out to be one special case of it, the Gaussian one, not a competitor to it. And that guiding arrow we kept drawing, the from here, which way is more real arrow, actually goes by three different names depending on the math you set up: noise, score, and velocity, but it is one arrow with three names, not three different ideas. You do not need any of that yet. You just need the shape. There is a vast space, mostly static. Real things hide on a thin sheet. A learned path walks the static onto the sheet. Everything else, every name, every model, every clever trick in this season, is a footnote to that one sentence. Next time, we draw the full family map.